inverse trig functions today. The three that we have talked about in class are inverse sine, inverse cosine, and inverse tangent. We've used them as calculator functions, really. We're not going to talk about them as calculator functions today. There are alternate names for the trig functions. Arc cosine is the same as inverse cosine. Arc sine is the same as inverse sine. And arc tan is the same as inverse tangent. Okay. We haven't talked about arc before. We're introducing that today. Just means the same thing. And so the type of questions you're going to be asked today are questions like, what is the arc sine of root 2 over 2? Unit circle type questions today. Most of them. So they're asking what angle has a sine of root 2 over 2? Does anybody know? What angle has a sine of root 2 over 2? 45. But so does 135. So does 405. You could keep adding 360. Also, negative 315 has a sine of root 2 over 2. Negative 225 has a sine of root 2 over 2. Could go on forever. Because of this, we need to come up with some sort of rule that narrows our answers down a little bit. Okay? And so for cosine, we're going to say that the only answers we're going to accept are the answers that are between 0 and 180. We're not going to accept all these extended answers of just adding and subtracting 360 from your simplest answer. So for cosine, the answers are going to be between 0 and 180. That's going to leave you with one answer. There's only going to be one answer between 0 and 180 for an inverse cosine. For inverse sine, your area that you can have an answer is between negative 90 and positive 90. You have to have an area where you can only have one answer. And for sine, to get the positives and the negatives, you can't go 0 to 360 or whatever because that has two answers. You can't go 0 to 270 because that includes two positive answers. So that's really the right side of the circle. The 0 to 90 section is the first quadrant. And then if you drop and go against the grain down into the fourth quadrant, that's where you get your 0 to negative 90. Okay? So that's going to include every sign possible. The positives on top and the negatives on the bottom. The inverse cosine is the top half of the circle. The inverse sine is the right half of the circle. There is no left half of the circle. Only the right half exists in dealing with inverse sine. Inverse tangent is the same as inverse sine. Okay? And now we can solve the mystery of why is STD painted on the wall? Well, inverse sine and inverse tangent uses the D part of the circle. Negative 90 to positive 90. So that's there to remind you that the sine and the tangent inverse functions use the right half of the circle to give their answers, from negative 90 to positive 90. Cosine is different. That's top half. Okay? So whenever you give an answer, like for arc sine here, the one I have up on the screen, The only answer of all those I listed that fits in our interval, negative 90 to positive 90, is 45. So that is the only answer that's acceptable. 45. Your calculator understands this. Your calculator knows the rules. We're not using our calculator to find these answers today. So let's do an example problem. The inverse tangent of negative root 3 over 3. We're not using our calculator. We're using a unit circle. So, thinking of our interval of negative 90 to 90, where in that interval are tangents negative, on the top or the bottom? Bottom, because the top, everything's positive. Okay, so on the bottom, you're going to have negative tangents because one of the sine and cosine, the cosines are positive, but the sines are negative. Because remember, tangent is sine over cosine. Looking at the angles down there, only two of them have a root 3. So it looks to me like we only have two choices. It's either going to be, and we cannot call them 330 and 300. We have to call them by an angle that fits in our interval. It's either going to be negative 30 or negative 60. One of those two has a tangent of negative root 3 over 3. How do we know which one? Well, we just kind of have to look at each of them and see which one it is. Sine over cosine for negative 30 would be negative 1/2 for the sine over root 3 over 2 for the cosine. Just looking at my unit circle. For negative 60, sine negative root 3 over 2. Let me fix that here so you can see the negative. And on the bottom, 1/2. So there are the two angles and their tangent setups. Can you look at those and determine which one is or which one isn't negative root 3 over 3 when it's simplified? Can anyone tell? By looking at those two massive fractions, when you would start canceling and simplifying and all that business, which one? Sam? Negative 30 is or is not? Because... Okay, he's making sense to me. Did you have something? Okay. I'm looking at the 60, and I see that if I just cross off the 2's, my answer is negative root 3. So I know negative 60 is not it. So I'm not a big moving roots off the bottom guy. I can do it. And I understand exactly what Sam is saying. But the first thing I saw was that it wasn't negative 60. And if it's not negative 60, it's negative 30. So I really never got to negative 30 myself. But Sam's right. That would rationalize to negative root 3 over 3. All right, here we go. Arc cosine of 1. You need to look at your unit circle and figure out an angle within cosine's interval that has a cosine of 1. Correct answer, 0. 0 has a cosine. You can't say 360 because 360 does not fit in the 0 to 180 rule for inverse cosine. Next question. Find the sine of the arc cosine of a half. What angle has a cosine of a half in the 0 to 180 realm? 60. So in the parentheses, the answer is 60. And then we are asked to take the sine of 60. That answer is root 3 over 2. What is the inverse sine of the cosine of pi over 3? Okay, the cosine of pi over 3 is 1/2. And then what angle has a sine of 1/2? Pi over 6. The reason I put it in radians is because the problem started in radians, and I figured I'll just do what they do. When in Rome. Arc cosine of the sine of pi. Sine of pi is 0. What angle has a cosine of 0? Pi over 2. We're going to do a couple more like this, and then we're going to move on to ones that you can't do on the unit circle. Find the arctan. Oh, sorry. Yes?
How do you know?
What angle has a tangent of -1? Well, we already dealt with tangents a little bit before, and we know that it's in the fourth quadrant because it's negative. And we dealt with two angles already today that had a root 3 in them. So it wasn't going to be either of those. So it's probably that -45 angle. Sine divided by cosine would give you that over that, which is, of course, -1. So the answer is not 315. Don't write that. It's not 7 pi over 4, because in arctan, you've only got the d. Our track that we're running around in this circle, we've only got a d. We don't have the whole track. The other side has been taken away. So we can't run 315 degrees. To get to that spot, we just have to go the other way, 45 degrees. Or pi over 4, whichever way you want to write it. So don't be using the big measurements. You can only drop. Let's try one more of these unit circle ones. Find the secant of the inverse sine of -1/2. The first question is, what angle has a sine of -1/2? That is -30. And then you're supposed to find the secant of -30. Well, to find the secant, first you have to find the cosine. And the cosine of -30 is root 3 over 2. So to find the secant, we just flip it and rationalize the denominator. Correct answer, 2 root 3 over 3. Not going to help you. But they look like this. And we're not using a calculator either. At least not using the trig buttons on the calculator. So we can't use a unit circle, and we can't use a calculator. What we're going to use is a right triangle. Here's what I mean. I can tell this is not a unit circle question. Can you tell by looking at it it's not a unit circle question? Because it's got numbers that don't look like unit circle numbers. There's only so many numbers on the unit circle, and I don't see a 5 anywhere on the unit circle. Okay, so what we're going to do is we're going to draw a right triangle. We decide what our angle we're at. We put a big clown nose or something on it so we know what angle we like. Okay, so that's our angle of perspective. We don't know what that angle is, but we know the cosine of that angle. The cosine of the angle is 3/5. So, yes. So, what we need to do is we need to label our right triangle so that the cosine of the clown nose angle, thinking of SOHCAHTOA, is 3/5. So, in SOHCAHTOA, cosine is adjacent over hypotenuse. So try to follow me here. That's that. Do you agree that looking at my triangle now, the cosine of clown nose is 3/5? Can you then tell me what the other side of the triangle is? Anybody? 4, 3, 4, 5 right triangle, Mr. Glass, geometry. 3, 4, 5. You could also do the Pythagorean theorem if you don't remember 3, 4, 5 right triangles. We're going to do this whole problem and we're never even going to know what the angle is. Because that's not the question. The question isn't what is the angle. The question is what is the sine of the angle. And the sine of that angle is the opposite over the hypotenuse, which is 4/5.
So what's the point in doing the inverse? Like the inverse.
All right. I want you to try this one. I want you to find the tan of the arc sine of 24/25. Same idea as the one above it. I've got a triangle, clown nose angle. The sine of that angle is 24/25. So we've got opposite over hypotenuse being 24/25. Using the Pythagorean theorem, which we all know. You could use your calculator for this part. I get that x is 7. 7, 24, 25 is another type of Pythagorean triple. And so now I want the tangent of the clown nose angle, which is opposite over adjacent, which is 24/7.